I'm Josh Wills. I am a software engineer at WeaveGrid. I'm a recovering manager. I used to be the director of data engineering at Slack many lifetimes ago, director of data science at Cloudera. And I drink espresso. And in particular, Blue Bottle's 17-foot ceiling is my just perfect. It is basically perfect espresso as far as I'm concerned. Just straight up double espresso is yeah, that's my happy spot.
My name is Chad Sanderson. I am the lead product manager for the data platform team at Convoy. And then prior to this, I was a product manager at Microsoft working on the big data team called the AI platform over at Microsoft. And I don't drink coffee, but I do drink green tea every morning.
I am stoked because we've got Josh Wills and Chad Sanderson. This is like Christmas came early for me. I'm so stoked to have the both of you on here. I know this was kind of last minute rearranging all of our schedules to make it work. It worked. I mean, originally, Chad, I wanted to talk with you. We had our first encounter. You came on the meetup. You blew my mind. I want to dive into more of this stuff. Since then, you've become somewhat of a LinkedIn personality. You might win LinkedIn's top voices for 2022. And yeah, your personal brand has been growing. You're killing it. You've got your Substack going. That is also killing it. It's been making a lot of waves in the MLOps community. Anyone out there that is not subscribed to Chad's Substack, go and do that right now. Do yourself a favor. You will not regret it. And last thing I will say, Josh, we got to plug this before we jump into it. Josh is going to be leading a course on data engineering for machine learning, I believe.
That's right. That's right.
And that's coming up in October. So anyone
September.
who is
September.
September. Oh,
mid-September. Yeah, sorry. Just had to get
October
the
if
date
you are a
right.
slacker. Yeah.
Yeah, exactly.
September, it's happening. Get after it. We'll leave a link to that in the show notes if you want to jump in to his course. And we should probably start, Chad, with what I feel like made a lot of waves in the MLOps community. You wrote an incredible blog post about data modeling. Can you just give us some background on that? What the hell is it that you're talking about for those who do not subscribe to your Substack? And then we'll start doing the good old fun of talking about why it's so important.
Yeah, so data modeling, if you're not super familiar with it, like the sort of elevator pitch is you're basically building relationships between like core concepts within your data. And there's actually two places that you can do this. So there's something called the physical data model, which is like how the relationships manifest in your data environment, you know, whether it's like Snowflake or whatever it happens to be. So this is, you know, the process of using dbt and you're joining tables together and all of that stuff. But then there's something else, which is like a semantic model. This is the way that I hate to call it like legacy or old school because I don't really think it's legacy. I think it's still pretty meaningful, and a lot of data architects still do this. Is like entity relationship design, and that's the like you find it and you think about the entities that are meaningful at your company, sort of abstracted away from any data-centric implementation. You then diagram the relationships between those entities. You think about the cardinality, like does it have a one-to-many relationship or many-to-one? You create this essentially diagram of the world, all of the properties that are relevant and sort of germane to each entity. And then that is what informs your physical model, like the thing that you actually build in in Snowflake or whatever it might be. The point that I called out is like that process of taking sort of a strategic, very thoughtful approach to modeling is not that common in a lot of cloud centric like data-based organizations. Convoy was certainly among them. What has become increasingly more common I've noticed is the ELT approach of like, let's just collect everything we possibly can from every source we possibly can, dump that into Snowflake or dump it into Databricks, and then we'll kind of like do a little bit of modeling just so that we can actually use the data to answer some business question. But it's not comprehensive. It's not like the full the full spectrum of relationships, which makes our data like fundamentally less useful. And then you see a lot of these basically the same queries being written over and over and over again. One reason because that happens is because the data model is actually like not comprehensive, and so people end up replicating things and duplicating things. I think that's a big problem. I think there's a huge problem there on like Snowflake spend. We're seeing this at Convoy now. Like if you do not have a great data model, you get a ton of replication and your spin goes through the roof. The complexity of the queries is quite impactful. And when you start achieving big data at scale, that query complexity is like very meaningful. Maybe when you're a small company, it's not, but once you start adding a lot of sort of data to the fire, it is actually pretty meaningful. And then just from the perspective of like the data being useful, like being able to answer questions and not having data engineers and data scientists and data analysts like constantly getting pinged from your business partners, like product managers. Like having a great data model solves a lot of that. So that was sort of the core of the piece.
It's so good, man. And who would have thought like data that is useful for people outside of the data scientists? That's a theory that we can all rally around. And I also think about like this idea of strategy and needing to have the strategy when you're going into things. And I imagine that you can get away with it. It's almost like the idea of technical debt, right? You can get away with it for a certain amount of time until you get to a certain level of scale. And you see that, whoa, now once we've hit such a large scale, we're not able to properly or quickly take advantage and gain insights from the data that we've got. Is that right?
I think that's certainly correct. And I think it manifests in other problems. Like there are, it manifests in problems around ownership. It manifests in problems around like there's a bunch of questions that are important for data teams to be able to answer that are just either not possible or it takes a lot of work. So a very common use case that I've seen happen is actually on like the customer service side or like data science for customer service or operations, where say you have some support ticket or you have like an email thread between like an operations person and a customer, and you're sort of going back and forth, and you want to understand if this particular thread or the service ticket or whatever it might be had some real world impact on that customer. Like, did they buy the thing because their problem was resolved, or did they not buy the thing? Like, what happened? If there's not a great data model in place to allow you to answer that question, it's really difficult to do. You end up having to write like, a whole bunch, like do a whole bunch of fuzzy matching and things like that, a whole bunch of case statements. Well, if this thing happened and this thing happened, and we see that like this particular shipment that we're kind of guessing might be related to the thing that we're talking about. Like you see a lot of that, and frankly it's just it's inaccurate. It's wrong. If you want to start automating those processes, it's really hard because you're going to be wrong like 50% of the time or more. It's really hard to build machine learning on top of that type of stuff, and it's everywhere. And then the last piece I would say is that there's fundamentally some aspects of the business that people are not even aware of, that they need to be aware of. There are these the way I like to think about a company is as a network, right? You actually have a bunch of different entities. They're interacting with each other all over the place and through life cycles. And what happens oftentimes is that product teams focus on like one particular piece of that life cycle. And if the modeling is not done pretty well, you lose out on a lot of the benefit of like, how does the entity that you care about interact with all of these other entities in your business? Like we have machine learning teams that are focused on our pricing model, for example. And there's a lot of things that impact a pricing model, but when the modeling is not done, it becomes incredibly hard to use that data for training and so on and so forth. So I think there's a lot of benefits to data science to having modeling done well, and some of them are not they're not completely apparent at
Chad,
first
hey,
glance.
I'm just gonna hop in here. How you doing, guys? How's
Yeah,
everybody
totally,
going?
Chad.
How's it going, y'all? You and I talked a long time ago. It was a long time ago. It was like one of our mutual VC friends introduced us. I don't even remember why we were talking about whatever, right?
Oh,
But in that conversation, you said something to me that has kind of stuck with me, and I've quoted it to other people, like, Chad Sanderson, head of data at Convoy. You said something which was the idea that the modern, the modern cloud data warehouses, right, have made it so cheap for me to just ask whatever question I want, relative to the old way of like, Teradata and OLAP cubes and all that kind of stuff, right? That it costs less for me to formulate and execute the query that I want to run than it does for me to invest in the sort of cognitive overhead required in understanding someone else's query, someone else's business question, and understanding, okay, what are the reusable components of that that I can then extract into my, you know what I mean, to answer
Yeah.
my question and like share that kind of stuff. And that was like deeply and profoundly insightful to me because again, like I'm super old, right? And I've been doing this stuff for like a long time. Um, like reading like the data warehouse modeling toolkit like back when I like started like right out of college in like 2001 was like a formative formative experience in my life, and like one of the true um like nerdy, I don't know, again, this is like, I don't know, there was one day where when I was working at Google where I met Dustin Hoffman and Jeff Dean on the same day, and like I was really excited to meet Jeff Dean while most people would be excited to meet Dustin Hoffman, right? um but like
Nice.
meeting Ralph Kimball, who wrote the data warehouse modeling toolkit, was like I had him autograph my copy and stuff. Like I was just
Awesome.
such a nerd about stuff, right? Um, that like yeah, this is sort of the core of the problem. I think, at least as you framed it, I think this is the core of the problem. It is now so cheap. I mean, I had a tweet about this once, which was like Snowflake's genius is that they have invented a business model where anyone can just throw money at a problem, right? I want to answer my question. I want it faster,
Yep.
and I'm just going to like throw money at this. I'm just going to spin up the warehouse, make it bigger, answer my question, right? And like, what a license to print money that is. And that being like the core of our problem, right? Is that in that we've moved fast, we have infinite scalability, infinite flexibility, and in getting so excited about these things, we have thrown out all of the things that were great about the old, again, to be fair, heavily resource constrained, single Teradata box. It's got 30 terabytes. That's all you have. You got to be careful with it. You got to schedule it. You got to plan. We've thrown out the baby with the bathwater here, essentially, right? And I guess like my question for you, man, is like, how are we going to put this genie back in the bottle? Like, how do we start to like unwind? Like, I think we're all kind of coming down from like the sugar rush, or
Mhm.
the cocaine high, whatever your preferred analogy is here, right? We're like, okay,
Yeah.
this has clearly gone too far. We've all lost our minds. Whatever your drug of choice is,
Whatever your
exactly,
drug
precisely.
of choice is.
Apple
Sugar.
juice, whatever. To each their own, right? Um, what do we do now? Like, how do we start? How do we start to fix this? Yeah.
Yeah. I think I think that's exactly the right question. And the one of the things that I think about, the sort of one of the comparisons I think about is actually GitHub.
Mm,
When people talk about GitHub, it's usually as I mean, nowadays it doesn't have a huge number of competitors, but there used to be a lot of people doing source control,
hmm
and GitHub sort of emerged because it did something else really well, which is it actually allowed people to um, be agile. It allowed someone to be agile, and all the principles of agile were like, you've got this idea of like creating like new branches and reviewing those branches, and like you could do like really great code reviews and make sure the right people are sort of in the loop, and you can physically see what's changed, and like you have alerts and monitors, like you have all this, you basically have all of this like really great infrastructure on how you move quickly safely.
mm,
And it sort of reminds me kind of where we are in data right now.
hmm.
Like what the cloud unlocked is our ability to move really fast, to your
A
point.
little too fast, perhaps.
But
Yeah.
there's a cost to that,
Yes.
right?
Exactly.
There's a cost to that, and it seems like the next step is to kind of regress back a little bit. Like we need to put the to say your phrase, we need to put the genie back in the bottle a little bit, but we still want to move fast, but we just need to have the safety guardrails in place, that allow us not necessarily to have like an extraordinarily well modeled system from day one, because I think that's just impossible given how startups are formed these days. Like hire 6 engineers, 0 data people, and like maybe a product manager and a designer. So it's just not feasible to actually have a great data model from day one. But what would be great is if it was very simple to, like, as these scalability problems start to emerge, you can modify your data model easily and quickly and do it in an iterative way. And the more your business scales and the more senior data people come on, instead of flooding them with service tickets, instead they sort of focus on, they take this like GitHub like approach where they're like, hey, there's some refactors that need to happen. Here's what needs to happen. I can do it quickly. I can do it in my sort of,
Hmm.
incremental part of the model over time. We can figure out like how do these various business entities relate to each other, and it improves incrementally. I think that that's the type of thing that has to happen. At Convoy, we've been trying to do this in a pretty manual way so far,
Hmm.
through the
Mhm.
idea of like contracts, data contracts, which we can. I mean, you wrote a post about this. I'd love to talk about it more, but like
Yeah, for sure.
contracts with this sort of abstraction on top of it of what I've been calling data design, or like data
Hmm.
UX, which is literally like a design surface for your data model that people can add to collaboratively. Like, okay, I've got an entity called a shipment, or I've got an entity called a shipper. I've got these like 12 properties, and I actually need a 13th foreign key so that I can answer like some question. And I should be able to add that really fast. Someone should review it. That should be enforced through a contract, flows into the warehouse, and then I can really easily and quickly answer my business question, and it's all safe. And I think all the tools
Hmm.
to do that stuff exist today. Like, it doesn't actually need any new, like, net new advanced technology or anything. All the stuff is there. It's just applying it.
Process workflow, like all that kind of good stuff. Yeah,
Yeah.
yeah, for sure. Um, See, I had questions and thoughts, and they all just got away from me, like all of a sudden, as it happens.
That
Um,
happens to me all the time.
it's
Don't
just
worry about that.
it's just story being a human, it's just the
Yep.
worst, right? So I guess Chad, what I hear you saying is like we don't need to throw the baby out with the bathwater. Like we don't need to like obviously no one is going back to the old days of whatever, right?
Right.
Um, I guess so. What you're saying is we can layer on contracts. And I guess a contract is a fun word for me. Contract is a new term for me because when you say contract, I hear in my head schema because I live in like the land of like protocol buffers and APIs and
Yep.
stuff like that, right? But obviously schema is an overloaded term in the data warehouse world. If you say schema to people, they're gonna be like, oh, you mean like schema, like a namespace in a database? And I'm like, no, that's not actually not what I mean, right? So contract. So I love contract as a word for this, just to be clear and disambiguate that we're not talking about like a literal database schema, right?
Right.
Um, you're saying this is a thing we can layer on to our existing data warehousing system. It's not a thing where we need to like go, okay, we screwed up. Because I mean, it's just a very human instinct, and you see this with like the DBT people are currently like completely rewriting their IDE from scratch, right? To just like let's just throw this out and start over. You know what I
Right.
mean? And I get that. I empathize with that, but I just feel like in my career I have learned that that is like 99% of the time the wrong thing to do. So
Yep.
is that what you're saying? Like this is something we can,
Right.
gently introduce, basically?
Exactly. Like, I
Yeah.
think I think that pretty much every business I've talked to about this, and Convoy included, usually has some set of use cases where contracts are, and sort of enforced schemas are incredibly meaningful. In our case, it was our pricing model, right? We had pricing model, one of the most important models in Convoy's business. It's responsible for like deciding the price of our auctions, essentially, like when we stop an auction. And um, the data was not good.
Okay.
Like, we were dropping, I think, 10% of the rows that we're feeding into our training set. And that was because there was a tremendous amount of transformations. There was a lot of stuff that was just randomly getting, like, columns that were being dropped upstream, column names that were getting changed. Like, the engineers like weren't really aware of what was going on downstream. And the reason that was happening is because we took this approach of, okay, like, software engineers, you guys don't really need to think about the data that you're emitting. We're just going to build a pipeline that pulls everything that you're capturing and dump it into our storage environment, and then we're going to build all of our training sets on top of that.
Yeah.
And turns out that's not a good idea.
It's not.
that's that's actually not a great idea.
Yeah.
But if we can say, hey, like, what if that didn't happen? what if we could make it so that this data was actually incredibly trustworthy, that there was a clear owner to it. It solved a very discrete problem, and the actual consumers of the data scientists, they understand the data that they need. They're like, I know what I need to power this model. I just need someone to implement it for me in the way that I want, and I need it to be trustworthy, and I need it to arrive on time. And that to me is the purpose that the contract serves. It does all of that through schema, um, and you can introduce this in a totally iterative way. One contract at a time, solve a business problem, get the value,
Yeah,
and then move on to the next one.
totally. Totally. I love that. This is an interesting, I want to say, I want to call it like a disconnect, Chad, I think between us that I think a lot, and I think about a lot for my course as well, right? Which is that I I guess I learned at, back in my Google days, right? So I was hired at Google like way back in like 2008 as a statistician. But as soon as I got there, all I did was write code because basically no one stopped me, more or less, right? Which would be like I wanted to analyze some data about how an ad auction worked, and so I went into the ad server and wrote a code request, and I added like the data that I wanted in the structure that I wanted it to do my downstream analysis, and sent it out for code review and like had it reviewed with the logs team because like at the time, like if you added like a single int field to the logs, that was like an extra terabyte of data every day,
Mhm.
which
Mhm.
was just kind of great, right? And got it approved, and my logs started flowing, and I got my data. And I have, for better or worse, like taken this attitude of like it's sort of a it's a what is it, Game of Thrones style, like I will take what is mine with fire and blood kind of thing to most of my career. Like if you're not going to give me the data I need, well, I'm going to go into your system and I'm just going to go get it.
Right.
And while I'm there, I'm probably going to fix a few bugs I find
Wow,
because
I
I'm,
love
to
that.
be perfectly honest with you, like much better at engineering than you are. And that's fine. And like that's the way that it works. And in small companies, that's kind of like that's the way because there is no, that's just the way it's done, right? But as companies get larger, like I don't scale. You know what I mean? Like you can't, and God willing, I shouldn't be allowed to scale. I guess basically, you need this. You need a process. You need contracts. You need
Right.
workflows. You need this because again, to handle this kind of stuff. And I guess like I have never successfully made that transition in my career. Like I am, for better, I am very much myself. So I don't know how would something like this work, in a big company where it's like there are too many people and you can't just go like cowboy this kind of stuff. So I'm,
Yeah.
I'm like that's the part that's most fascinating to me about like what you're talking about. Yeah.
Yeah. Yeah. I mean, man, I would love it if
You
more.
you would love me at Convoy. I
I
would be like your right. I would be like your
You,
ninja.
you
You
would
would
you
just
would be
like I would just
amazing. You would be amazing at
I
Convoy.
The
That would
perfect
be.
pair.
right.
It's so funny that you say that because that has traditionally been my experience. That's been my experience as well. There's just such difference between like companies of different scales like
Totally.
it's something I didn't even realize until I joined Microsoft, and then I joined Convoy after that. You know, in some places there's almost like a Stockholm Syndrome type thing going on with the data consumers
Exactly.
where
Exactly.
they're like like I'm not allowed to go up and touch this database or whatever. I'm
Totally.
and so I just need to accept everything, and
It's very.
because
I call the Oliver Twist thing. It's like the please sir, may
mm,
I have some more kind of thing.
yeah,
Like it's
yeah,
like please data producer, please let me have some
please
data.
please
And I'm just
please
like,
help me.
man, I'm saying, Demetrius, can I swear on here? I've been swearing for a while, haven't I? Is that okay? Okay, so I'm like,
Oh
I'm
yeah,
like, fuck
yeah, yeah.
that
That's all good.
shit.
Yeah.
Fuck that. I am gonna go in and get it. I don't care. This is how I was taught. This is
Yep.
how it was done. Like I don't like
Mhm.
I don't know. I want this to happen on my timeline, not your timeline. Like anyway,
And
yeah,
honestly, I think that like I think that is so the thing that I have felt sort of as a data platform lead is that what's really missing is the interaction between the producers and the consumers, and
yeah,
if the consumer's just going to go up into the warehouse, they're going to go up into production and make some change, and the producer like doesn't like that, great, like that's now a conversation that can happen, and we can talk
totally.
about like like this data is important to me. You weren't like you weren't getting it to me the way that I wanted, so I did it. So if you don't like it, we need to talk about our options here because I need to run my model and whatever. But what I find is that I don't know if it's almost like a meekness or sort of an acceptance of like, well, I can't get the stuff that I need. I ask people for this, they don't give it to me, and so instead I'm going to spend a month like writing SQL in Snowflake
or doing some crazy analysis instead of just going and getting exactly what I need.
exactly. Yeah.
I'm gonna build a machine learning model to impute the missing features that I need to train. Like it's just like it's absurd. Just go get the goddamn
Right.
data. Like what is wrong with
Right.
you, right?
Yeah.
But I think what I feel like we're saying here, and I think this is important, and this is the part I lack, right? Is like you basically need a carrot and a stick model,
Yes.
right? Like I'm the stick and you're the carrot.
Yes.
Because I'm just saying, like if it's just all carrots, it's not going to
Mm.
work, right? But if it's all sticks, it's not going to work either. Because I mean, again, inevitably I get fired because someone takes me out. Like
Right.
it's every ninja goes down eventually. No one survives forever, right? It. So I mean, that's the thing is you need that sort of pairing basically. You need to figure out like what is your carrot stick strategy for moving this stuff forward and making this happen.
Yeah.
That's
Yeah,
fun.
and
That's useful.
you're right, and
Yeah.
I think that's so. Here's sort of an interesting thought that I've been having, and I'm still trying to express this in a way that's like not confusing, and people don't yell at me because I get yelled at a lot on LinkedIn. Is
I love it, man. You do, and it's
That's the best
I
part.
thoroughly enjoy it. Like I love your posts are the best. The comments are fantastic. Anyway, okay,
Yeah.
yes, please.
But so one of the things, so I sort of I've been thinking a lot about this like GitHub comparison, and I think at first when I was approaching this problem at Convoy, I was approaching it basically the way that you were saying, which is a data scientist or someone would come to me and they'd say, hey, what's going on with this quality? Well, I don't understand why it's so bad. I was like, well, you're a software engineer, like, and you care about the quality, so you like it should be on you. Like, go do it. Like, go get it
Yeah.
done. And
Yep.
but there was like a real hesitancy. There was a real hesitancy to do that, and I think a lot of it has just come from organizational design. A lot of it has come from sort of this clear separation of
Culture.
concerns, like mounting
Yes.
expectations of like we don't the business like doesn't care if you put a lot of time into data quality and sort of data governance and things like that. We just want the model and we just want give us the report. And so I need to like maximize my time as a data person to deliver those things. And now if I have to add sort of quality and ownership of some upstream like production thing into my workload, that's going to be a net negative for me. So I need to find someone else to do this. And the software engineers aren't listening, so a lot of the times like those things get redirected to the data engineering team. Like, hey, the pipeline broke, go fix it, data engineers. I can't yell at the software engineers, so I'm going to yell at you instead, because you have to
Exactly.
listen to me. And
That is so true. Okay, go ahead.
oh yeah. But all I was gonna say is like what that's kind of led me to feel is that the sort of GitHub based approach doesn't actually work for data if the consumer, if they care about the code and they care about the quality, then that's great, and then it does work. But if you're living in a world where they don't care and they're basically just saying, I just want you to give me like this particular data asset, like when I need it in this form at this time, then code may actually not be the right level of abstraction for that.
Okay.
And so we're sort of moving to a world at Convoy where what we're trying to do is abstract the code and instead focus on the semantics and like the data itself. Wherein
Okay.
wherein someone might be able to say, for instance, there's like a real world thing that happens. Let's say a shipment has been canceled, and I want to know every time the shipment has been canceled, and I want to know that in real time. And here's what a cancellation means to me. And there's like six different places. There's like in a life cycle, there's 6 different places where that cancellation could occur. I want to know all of them, and here's like the properties about those cancellations that are meaningful to me. All of that can actually be described using English and semantics.
Yeah.
And
Of course.
and,
Yep.
and if you're able to capture that as schema, and then you either an engineer or a data engineer or whoever else, you have some agreement, and that's something we can talk about. But if there's some agreement to actually implement this as a contract, then once that data flows into, your lake or your lake house or your warehouse or whatever it is, you can essentially map the semantic meaning to like the actual code in the warehouse, thereby abstracting the code. So if I want to make a change, I can make a semantic change. The engineer understands how to do that from like the schema sort of code perspective, and I can go and train my model without even needing to think about like, oh, okay, I need to go into production and write something.
Dude, you said so much, and you have to forgive me. I'm going to comment on like three different things you said because they're each
Yep, I
like
said a
so
lot there.
important.
So
You
sorry.
did.
Sorry
No,
about
no, it was great. No, it's fantastic. 'Cause it's basically like if I could just take that your little like the speech you just gave there and just turn that into like an ad for my data engineering for ML course, like that would be like
that.
ideal. Like just because one,
We'll
you
clip
hit on
it.
all the
We'll make
things.
a clip. Don't worry,
What'd you
Josh.
say? What's up, bud?
We'll make a
I
clip for
appreciate
you.
that. Thank you. Thank you. Spear will be grateful. Um, First thing you said, which I think, which is really like the reason I want to teach a course is because there is some things about the reality of doing data that cannot be talked about in podcasts and cannot be written about in blog posts, which is like the implied social dynamics, like cultural hierarchy of various engineering teams at various companies. Like this is a very real thing. Anyone who does this stuff for real can like talk about this, right? But we never talk about it. We never talk because it's very touchy. It's very sensitive, right? It's not something that can be like discussed out in the open. You need like I mean, I don't know, say you need like a group therapy session or something. And that's to a certain extent like what my course is like it's a place that's private, you know, where like the entrants are screened for practitioners, like we're not like like where we can have these sort of conversations about these things and how do we deal with this, right? The second one I want to say, and again, this is just again like advertisement for the two topics for the first session of my course are one, data collection, right? Obviously because it's so foundational, and the second one is data quality. And I think like a lot of people, I have very much had the challenge of how do I sell data quality like as a thing we invest in, as a thing we like do time, like we put money into. And I think what was funny to me was I've been reading up on how different companies handle this, and I love, love, love Google's wrote this wonderful paper about their data validation system. I don't know if you've
Mhm.
come across this. It's actually like it's actually largely open source. It's in the TFX, the TensorFlow Extended System. It's this data validation library they wrote, and basically, so again, talking to my friends at Google, it is like taken over at Google, like data validation, data quality with like clear defined schemas, specifications for like what values are allowed for different fields with what tolerances is everywhere. It's everywhere. They use it for everything, like all kinds of stuff. It's completely taken over there because the data quality stuff, it does really like three different things. One, it's documentation. Like what does this model expect? What inputs does it need to see for it to work correctly, right? That's like so it's documentation for new engineers exploring new models. Two, it's actually like they use it for testing. They will use the schema and the specification, the contract, if you will, to auto-generate training examples that are designed to push the limits of the schema. Like, let's intentionally throw some weird data into this model and see what
Hmm.
happens and see what
Yeah.
breaks. And it
Love
catches
that.
bugs. So it's like fuzz testing effectively, right? And the third thing, and this is the most important thing, and just this is like, to me, this is separates like people who can do ML from people who can't. Google has learned through trial and error and lots of years of mistakes that there is free money in doing a better job of constructing your training data set by using data quality checks to basically test extremal values, rebalance your classes. There's free money in there. You don't need a better architecture. You don't need new features. You don't need anything. You can do a better job of constructing your data set using these data quality metrics as a guideline and get like a 3 or 4% lift. Like, you'd be insane not to do that. It's like literally free money. Anyway, I'm sorry, I shut up about this, but like this is the stuff I want to talk about because it's not getting talked about, and this is my opportunity to try to fix that. Yeah. Anyway, I'm sorry. Oh yeah.
There is something that
Oh yeah.
I wanted to touch on, which I think is a bit tangential to this, but stay
Okay.
with me and I'll bring it back around. And it is going back to this point where you've got some data that maybe has been it's been tainted along the way, along its life cycle, along its journey. And that's because somebody upstream did something with it. How do you make sure, or how can you get someone, anytime that they touch data or they mess around with something in the database, they know everyone that it's going to affect, like those second and third order effects?
Totally.
Yeah. Okay. So there's a few things there that I think are really interesting to talk about. I think the core of your question, the core of the answer is lineage. The problem with most lineage systems today is that it's just metadata collected off of the warehouse. Like you pull out Snowflake metadata and you can build a lineage system based on that, and you can see how various tables are connected. But to your point, there's nothing that actually ties all the way back to the services themselves. And if you had that, even if you went that one additional step, it actually becomes an order of magnitude more valuable for like three different reasons. Like one is sort of what you said, which is if you're a data producer, today data producers have literally no idea what's going to happen if they do anything.
Yeah,
Like
totally.
they drop a column, they're like, I don't know, like I don't, who knows? But if you did have
Until they
some sort
get
of lineage
called.
component, and that I could go quite deep with this actually, but if you sort of combine this idea of contracts and lineage together, then the data producer could essentially know, like, if I am going to drop a property or change a name, I can go out, check my lineage, see like who are all the consumers of this, and go all the way downstream, and then be like, listen, if you make this change, and you do it in like a non-version controlled way, you will break our pricing model. Like you will break the training set for our pricing model. And just having that level, like being told that you're going to break something before you break it, is I think would fundamentally change how software engineers interact with data. It's not that like producers don't care, like they would just break the pricing model even if they knew that it would happen. They just don't know what's going to happen, and how could they? Like they're not really brought into that part of the data lifecycle at all. So yeah, I think that would be really important. The other thing is like there's not really the idea of like a backwards incompatible change when you're like managing database changes. Like there's the idea of that change like sort of within the service, but not within, like what's going to happen to all the consumers of this, which is another area I think data contracts is really amazing, because you could essentially say like, hey, we understand what this schema is supposed to be. There's a contract here, and the change that you're going to make is going to be backwards incompatible. Like, are you sure you want to do that? Is this really the best thing for you to do? And if it is, if you are going to have to make an incompatible change, we should at least tell people what's coming, and be able to communicate to all the consumers like downstream. So
Yeah,
like that would be, I think, massively beneficial.
I would say a couple of things there. Like, just sort of like riffing on what Chad was saying. Well, like one is that, so at Slack, first and foremost, we relied primarily on our structured logs. Like we had thrift schema for our structured logs that were designed to go in the data warehouse. And that was obviously integrated with code review, integrated with CI/CD checks, such that if you introduced a backwards incompatible change to the logs, the CI/CD check would fail. Oh, there goes my dog barking. That's good. I'm gonna go. She probably just wants to get up. I'll go get her. The CI/CD check would fail, and exactly that. You could, again, it could be overridden, but you had to have a conversation with people before you did it, right? That kind of thing. Two is like, it's certainly the case that people like unintentionally, like through ignorance or whatever, do these changes and stuff. But in my experience, the bigger problem is really just like honestly bugs, more or less. Like no one meant to break the thing, right? They didn't mean to break the pricing model, but they introduced a bug, and so therefore, this RPC call like stopped, that was actually critical, stopped working silently, and no one noticed and stuff like that, right? So I just want to call out that, like, for me, in my experience, insofar as like schemas and contracts up front, remove just a, a huge class of just the knucklehead stuff, right? Like the unforced errors, which is key. That doesn't mean that you don't need data quality and data validation stuff downstream, because again, bugs happen. Nobody's perfect. This is normal, and so but again, we have to be defensive against it, because it's, especially with ML, it's just way too easy Chad, as I'm sure you know, for like this stuff to just slip through and like no one notices, right? Until you end up with like a model that like is just, is terrible. Anyway, so yeah,
Yeah,
good call of
I
the
think that's a
Dimitrievs. Yeah,
I think that's a good point, and to sort of continue on that, I do find that in the data community and even in the data science community, again, there's I use the term Stockholm Syndrome, where there is this expectation that like we need to put all of the quality checks downstream,
yeah,
and like you said, there obviously does need to be like you don't want to just leave your fate up to the hands of the gods, and
of
and
course.
like hope for the best. But at the same time, it like having the people who are producing the data also having
Yes,
a skin in the game when it comes to quality is
yes.
is incredibly meaningful. I think one of the questions, and Josh, I'm actually interested to hear.
Oh man, I was just about to ask you a
Oh,
question. You can't do this to me. Come on.
I'm
Okay.
interested to hear how you sort of how you handle this at Slack. Is
Yeah.
the biggest sort of feedback I get from people when I talk about these things, and even earlier at Convoy when I was pushing a lot of these ideas was like, well, the engineers just don't care, right? It's just not. It's like the engineers don't understand that this is something that they need to be able to do. It's like an additional like category of work that they need to take on. It doesn't actually benefit their service in any way to do all these things. So like, how is that something that
Yeah.
just adding these quality checks at Slack? Like, how did you overcome that, and sort of how do you think about it more broadly?
That's just a perfect question, man. It's a perfect question. And it actually it's funny because it gets exactly to what I was going to ask you. Um, and my answer, and I'm going to answer your question, and I'm going to ask basically my question like right after that, back to you.
Okay.
Okay, right? So the answer is that we hired engineers who cared about that data, and we basically, you know what their title was? Their title was machine learning engineer. That was their
Mm,
title. Because the machine learning engineer, unlike literally every other engineer at the company, is basically the person who is going to both generate the data upstream in the production service and consume it and process it downstream in the data warehouse. They actually have, to your point, skin in the game and a stake in the fact that the data they get for their model to work and for their life to be good and happy, these things need to work, right? They're incentivized in this way. Okay? So ML engineering, at least at Slack, was the first best customer for all of this stuff. They wanted the schemas. They insisted on the schemas, right? They needed the schemas. It solved their problem because they, again, were the only person who lived on both sides of the fence here. Now, once we had built the minimal tooling, again, contracts, all the downstream data processing, all data quality checking, all that kind of stuff for those engineers, then it started to grow. It started to expand. And then, like, the growth engineers. So, I mean, I would say, to me, like, broadly speaking, in any company, there are only like three, like, there's like four use cases for data, and three of them are things that engineers care about, right? One was obviously ML, obviously. Second is growth, like growth, product-led growth in particular, Slack being like obviously the canonical product-led growth, the original product-led growth company, right? So then the growth engineers started cottoning onto this and like working with their data scientists. And they started build what was great about the growth engineers, like for the ML engineers, like again, love ML engineers, we built like the most minimal sort of shitty tooling possible, right? Just the minimal acceptable tooling. The growth engineers come along and they've got like their front end shops and their full stack, and they just start making our tools. They start using our tools and they're like, wow, this is garbage. Like we're going to make this much better, right? So they start building the tools and adjusting them for their needs, right? And then the last one was really the performance engineers. And this was my favorite one, was like when we started getting very serious about performance, because performance and like cost, cloud spend, all that kind of stuff, the performance engineers started coming in. And then they started using structured log to capture like weird database query edge cases and like teams that were having cache misses way too often, and they started getting serious about this stuff, right? So it all kind of spiraled out from there. But I think, and this is back to where I'm questioning to you, if I don't have those engineers who were designed to cut across the data warehouse, I don't know how to get started, my man. I don't know how to operate in a world where you're exactly right, because like the regular engineers don't care. They absolutely, and again, I've been a regular engineer. I empathize. They have to worry about security. They have to worry about, obviously performance. They have to worry about functionality. The product manager wants this. Like they have to worry about 800 million things. And so I feel terrible piling on another thing they have to worry about, especially if like the tooling is immature and stuff like that, right? So, dude, that is
Yeah.
a problem I don't know how to solve. To me, that you solve the problem by hiring ML engineers and making them the first best customer for the stuff you're building because they do care. It's in their interests
Yeah.
anyway.
I totally agree with you. So I can tell you, I can tell you one of the ways that I've thought about this at Convoy, and
Please.
a bit of it is somewhat authoritarian, I guess. So who knows?
That's great. I'm a big I'm the stick man. I'm with you. Let's do it.
Okay.
Carrot and stick. Let's bring some stick. What do you got?
Yeah, yeah. So so I've basically found success in two main ways. The
Okay.
first way is actually with the underwater data engineering team. And where the data engineering team right now, they're a lot of them are software engineers. They're building these pipelines. The stuff breaks for reasons outside their control, and they are essentially sort of caught in between, the pincer of like the software engineers who are owning these like upstream things and sort of the downstream folks that are just causing them all sorts of pain. And
Yep.
that was actually where a lot of these ideas originated at Convoy. Was the data engineers who were like, can we just go and solve this problem ourselves? Like, can we just
Yeah.
go in and very, very easily like create, like add the data that we need, add the data that this downstream team needs, build it as a contract, and then hand it off to that software engineering team and say, hey, if you make any additional changes to this, just understand that like there is some process in place, like there is some CI/CD workflow where if you make a backwards incompatible change, like you're not going to be able to do that, or you have to alert people. And
Yep.
generally speaking, like that additional level of ownership, which is basically just owning an API, was like not super painful for anybody
Totally.
involved. Um,
Exactly right. Yep.
and so that was actually really helpful, and the data engineering team loved that. And there was a lot of use cases when I remember we were trying to get this rolled out to certain to software engineering groups, sort of in the organic way that you were talking about. There was just sort of gradual adoption as people realized like, oh man, these contracts are awesome. And sometimes the software engineers, when they were first starting to adopt, was like, hey, we're going to budget, a week or maybe a whole sprint for doing this work, even though it might just be adding one or two properties to an existing thing. And the data
Hmm.
engineer said, yeah, I'm just going to go do it myself. Like, I'm just going to go in. I can do this in like 10 minutes, and then it's done. And that would
Exactly.
happen a lot. So,
Exactly.
um,
But then at the same time, dude, I see so many places where like, the data team and the prod team aren't even in the same AWS account. Like it's bizarre. Like literally physically, they're like, I mean, again, physically in the before times, right? In the before times, they'd like physically be sitting like 10 feet apart, but like technology wise, they would be living in like completely and utterly different universes.
Galaxies.
They're galaxies away. Yeah, precisely. That like the production system and the data system, to your point, like Chad, live in completely different worlds. So I am curious for you, like the first time this happened with the data engineers, like how did that go? Who did they talk to? How did that work? Was there a meeting? Was it like just a Slack DM? How did that work?
yeah. So there's so the type of tooling that we build is probably similar to maybe what existed at Slack, but like we essentially created there's actually two things, and this is gonna sort of help. Then I can explain the process that happens sort of as a result of the tools. Is we essentially have sort of two things. We have one thing that's like an SDK. It's like we don't use like protobuf or Avro at Convoy,
Hmm.
so we have like an internal sort of IDL that we built. It's
Oh,
like very
nice.
similar.
Is it like JSON
Um,
schema? Like what is it? Is it?
yep,
Yeah. Okay.
yep,
Nice.
yep. It's JSON schema.
Right on.
Yep, and so we basically created a library, put like CI/CD checks around that, made it like really really simple to like emit these things that we called events, but they could just be like a database change could be an event theoretically. We were actually mainly focused on this other idea, which I can get to a little bit later, called semantic events, which are like capturing real things that happened in the world.
Mhm.
And there's a reason that we focused on that is kind of an answer to the question you just asked a second ago.
Okay.
And then the second piece that we built was actually a abstraction of the production table itself, that sort of lived in the stream processing layer.
Mm.
And so the idea was, if you're an engineer, you could basically wrap your production table in this abstraction. You could say, I only want to push these like 7 or 8 things that are within a contract into the warehouse in sort of a structured format. Everything else I can just continue to dump and not think about. And then and there's like some really interesting things that go along with that. So in that way, we were sort of capturing as events, like as sort of clearly defined schema with a contract, every single update to sort of the important entities within our databases. And then we also had sort of these backend events that were being emitted from the services by the software engineers or the data engineers if it was simple. So the goal through like those two pieces of technology was like, we want to make this as unbelievably simple as possible for anybody to do that understands, like, like you can write JavaScript or TypeScript or something like that. It's just real easy. And then the pipeline is actually auto-generated. Yeah. So we would say, okay, we would check the contract, we would create a new Kafka topic, push that event via Kafka into the warehouse. We'd automatically parse it, like once it landed in Snowflake. And so you sort of, then you can actually, we built another thing that's like a catalog that sits on top of that, essentially links the contract to the schema registry, and
exactly.
to the underlying like Snowflake table.
Totally.
And so there's sort of a clear line of sight there. And so what happened after we sort of had these two pieces was that we had a data science team. Oh, and this is another piece of context, is data engineering at Convoy is actually like a centralized organization. They're not embedded. They're actually technically part of the software engineering organization. They're not a part of the data organization. And so what happens is that the data science team would say, we've got some data that's breaking. They would sort of make their traditional complaint to data engineering, like, this is a problem, can you guys go fix it? And what we did is we initially worked with them to say, what is the data that you actually care about and that you need? Mm-hmm. Do you know what service that this data is coming from? And if not, we can go figure that out for you. Yep. We went out and basically did that. We said, okay, we figured out that like the data you need is coming from this service, and the way that the way that we can express the data set you're asking for is actually through like maybe 3 or 4 real world semantic events. Like, you want to know every time that a new auction is completed, every time like a new auction there's like a bid is made on that auction, and every time like some customer I don't know, makes a bid, they press a button in the app to say like, let's, we want to have this auction. Okay. And then we need to add like 3 or 4 new properties on the actual like auction entity. And with like that combination of data, we can hand that off to like a business intelligence engineer, and they're going to be able to derive like whatever data sets that you need. Totally. The data engineer went in, they implemented that in like a day. The data flowed through in real time, and then the BI engineer was able to, like, since it was all properly modeled in advance, it took them like 2 or 3 days to build the data set. And
easier to build the model, cheaper to build the model, so much cheaper to build the model, right? Because I mean, the cheapest time, this is like one of my things I harp on, like the cheapest time to do a join is the moment the data was created, by far. Everything after that, streaming, Snowflake, way more expensive to do the join then. Do it when it's cheapest. Oh my God, if you can. Oh, I love that, man. That's fantastic. I love that. I mean, that data engineer you're talking about, whoever was doing that, I mean, that sounds like an ML engineer. I wouldn't utter that person's name lest the recruiters like descend upon them after hearing this. So just keep that one to yourself.
I will for sure. So there's one use case that I want to give you, which is really helpful in thinking about this. And we discovered it a bit later. Is there is actually a product use case here too. And the product use case that we found, this is sort of why we sort of been pushing for this idea of semantic events. And we found that a huge number of the questions that like both data scientists and product managers want to have answered is like, I want to understand in a sequence of like, what are all the things that happen to a specific entity in some order. And then and then like there is some set of like real world funnels that exist. And then I basically want, so an example of this might be shipment cancellations. It was really hard at Convoy to figure out, you know, who was responsible for a shipment cancellation.
Mm,
Is Convoy responsible for that cancellation? Did we like mess up somewhere? Did we get the wrong information from a shipper?
mm,
Like why did this person
hmm.
cancel? And the only way that you can know that is by like looking at the log
Yep.
of everything that happened in the sort of history of that entity over
Yep.
time. And this was like a huge product question. Like this is something that, you know, if you could answer that correctly, you know, there's like millions of dollars that we could potentially be saving. And we didn't have a great way of doing it. We are like, well, you can do it through contracts. The way that you would do it is you would say, let's look at the life cycle of this particular like shipment event, of this particular like shipment entity. Let's like very, very clearly document like all the things that would be germane to cancellation that would like cause a cancellation. Let's instrument that like in the code itself through a contract, clearly defined schema, well modeled in advance. And then once it flows into the warehouse, we can basically generate that sort of history table of that particular
Sessionize
entity.
it. Yeah. Totally.
And then all you have to do is it becomes trivial at that point to solve that. So
Exactly.
we actually found that a bunch of product teams started asking their engineers for that, and then contracts
Ah.
were the mechanism of implementation.
That's super smart, man. You can get really, if you can tell a product manager that they can have a funnel for something, oh my God, they'll do anything you want. That's dreamy.
Exactly.
I think I want to call it here is like again, like one of the themes of my course, and I'm sorry to be like a broken record about this stuff, right? Is about like relationships between engineering teams. And the funny thing is like is this pattern of analysis of like the sequence of events occurs all over the place. They call it like customer journeys over in marketing land, right?
Yeah.
And then but at the same time in like the land of observability, this is traces and spans. This is like what
Yeah.
is the life cycle of a request? When does a request die?
Right.
What's the
It's
Yep.
the
slow,
same
right?
thing. Yeah.
And so it's all the same thing. And the joke to me is like literally it's the same thing. It's the same technology. Now, your example is perfect because it's like for these custom things where it doesn't fit naturally into like an e-commerce, conversion workflow or like a trace on a request. The data teams are left with constructing these custom systems basically to do these, exactly this kind of stuff,
Right.
right? And the funny thing to me is like the price point of like constructing this funnel changes dramatically, even though it's the same problem, like
Yeah.
the engineering challenge is essentially identical, but like for observability, it's like not that much money, and for marketing, it's like extreme amounts of money, like that kind of thing. I'm sorry, um, but yeah, it's just funny to me, and I love these conversations just because we get to talk about this stuff. It's so fun. Dude, Demetrius, it's like 10:20, and I got to get going. I'm sorry.
I know. I wish we could
Yeah,
talk all
I know,
afternoon. I know you got
I
to
know.
go. I appreciate both of you coming on here. Got to be a fly on the wall and just watch you two chat about this stuff, which I was hoping to do. I'm so thankful for this happening, and maybe we can do it again sometime.
Never know, right? Just ping me randomly like 10 minutes before you want to do it, and I'll let you know if I can. Okay.
If you're free, that is it. Well, this is awesome, guys. I